A few weeks ago we made a complete disassembly of IBM's epic PS2 P70. This IBM was actually a rental back in the day, and unfortunately someone seems to have dropped it. We have since then repaired the diskette drive, a spare hard drive and a motherboard. We have also fixed the keyboard with printed parts and tried some overclocking. In this video we are going to fix the PCB on the display and the display latches. We are also going to have another go at overclocking and check with the post reader to see if it will give us any clue to why it didn't work. My theory so far is that the BIOS deliberately stops this machine from overclocking, just like in the original AT. If all goes well, we are also going to reassemble this IBM. This video is sponsored by PCBWay for a very good reason. More on this later. Thank you PCBWay for supporting this channel. As I was about to wrap up this project and reassemble this machine, it suddenly started to smell fish. So if you have been messing around with vintage gear, you know exactly what happened. The caps at the back of the display have started to leak, and when the display warmed up, it started to smell really bad. So before we can continue, we have to fix this. As I was ordering caps, I thought I'd try something new, because these radial caps are quite expensive. So instead of ordering matching caps, I ordered cheap radial caps instead, and I'm going to bodge them to fit. So let's see how this goes. So I'll just bend the longer leg like this, and then I'll just bend it over the cap like so, and then I'll bend the other leg like this. And we sort of have a radial cap now, but way cheaper. As far as I know, the only difference between radial and axial caps is that one of the leads is coming out from the other side of the cap. So I can't see any reason to why this wouldn't work. I guess we will know for sure in a minute. The through holes on this PCB are absolutely tiny, so I'm actually having some trouble here removing these caps. Let's add some fresh solder and see if it helps. Okay, let's try again. Well, that looks better, but I'm not sure I got all that solder out. Let's pull gently on that cap. No, it's still stuck. The legs of the original caps are really thick, so the through holes are pretty much filled up with those legs. So that's why it's so stubborn. The leg is stuck to the sides of the through hole. Okay, now it came out. So the legs of the original caps barely fit these through holes. These new caps are quite a bit smaller than the original caps. As expected, of course. I had to raise some of the caps off the board to check the values. So that's why some of these caps are standing up on one side, like this guy here. Not sure how well this will show up on camera. It's quite clear that this is one of the caps that is leaking, because there is corrosion on the pad. I actually had to add some fresh solder on this side of the board and then remove it to get rid of the corroded solder, because it just wouldn't melt. But now that's fixed. There aren't that many caps on this board, but it's still not a quick recap, since so many of them got stuck. Ooh, this one smelled really fishy. Yuck. By the way, I wasn't able to find a datasheet for any of the caps on this board, so I just went with regular caps rated for 105C, and hopefully that will do. Well, I'm a bit worried about the size difference on these 1 microfarad 250 volt caps, but without the datasheet I don't really have a choice. Okay, that was the last cap. I'll wash the fishy smell off this board and we'll try it out. Here's the list of caps if you're ordering part for your projects. C10 and C37 were not marked, but the rest of these caps are rated for 105 degrees Celsius. Okay, so the first thing I want to try out, as suggested in the comments, is to check if it's the display that doesn't allow us to go faster. So external display connected to the board, and everything seems to be working fine. So let's pull that original 40 MHz crystal off the board and install a 50 MHz crystal That should bring the board up to 25 MHz. Let's turn the power on and see what happens. And unfortunately, absolutely nothing. Still a black screen. Okay, so the issue is not the display then. So in that case, let's install the post card in the parallel port. Okay, card installed and powered. Let's turn the power on and see what the board does. Oh, nothing apparently. With that crystal, this board doesn't do anything. Let me reboot and check again. No, the board is stuck at 0. That board isn't doing anything at all. So unfortunately that didn't give us any clues. By the way, I've never used this card. So let's give it a try with the original crystal installed on the board. Oh, it is working. So it's giving us postcodes. Okay, that kind of sucks. Because that means this board isn't doing anything at all with a 25 MHz crystal. With the original crystal back on the board, it's now working perfectly. Well, in that case, let's try something crazy. So the P70 is sort of like a luggable IBM Model 70. So I wonder how this board will behave if we install the BIOS from a Model 70. These are 27C512 chips. So it's not going to damage anything if we try. This could be interesting. Well, according to the postcard, it's doing something. This is with the original crystal, by the way. Unfortunately, it stops at 0D and then just a black screen. Well, this board is actually clearly marked with odd and even, but my Model 70 board is not. By the way, these are from a Type 3 and 4 motherboard. So let's swap them around and see what happens. Okay, fingers crossed. Unfortunately, the postcard is just showing FF and nothing happens on the screen. So then we know we can't use Model 70 BIOS in a P70, at least not from a Type 3 and 4 board. Okay, so how about with an XGA2 card? Let's turn the power on. This is with the original crystal, so I'm just checking if this card is compatible with this board. By the looks of it, I think it is. So we got a 165. That just means found new hardware. But I don't know what this code here is, so I'll check it. 14901. Okay, apparently that is the onboard graphics adapter. So not sure why it's giving an error. But it doesn't matter at the moment. We can check later. But for now, let's just pull that original crystal again. And try again with a 50 MHz crystal. This crystal is tested, by the way. It's from the Commodore 486 SX25. Okay, let's turn the power on. Postcard is not showing anything. We're getting nothing on the screen. Well, this kind of sucks. I don't really have anything else to try at the moment. Okay, well, that is a big pile of IBM parts. I couldn't quite fit everything in the frame, so I've got more stuff on the side here. And there is, of course, more parts underneath here. Everything has been washed, so all the parts are nice and clean. So let's start rebuilding this IBM P70. The keyboard has been partially reassembled already, but removing the lid was the most difficult part of this entire project. So I have done a very thorough test of this keyboard, just to make sure I never have to lift that cover off again. The spacebar had yellowed, so I left it in peroxide. It's a pretty good match to the rest of the keycaps. I have repaired this keyboard in a previous video, because these tabs here were broken off. So we have replaced them with printed parts that I ordered from PCB Away. I don't remember which side the spring was installed in, and unfortunately I didn't take any pictures, but hopefully it won't matter. Actually it does matter, because there is a peg on this side. Well, not really conclusive, but I think the spring should be on this side. And finally, put that lid back on. And the keyboard looks and feels great after the wash. It's pretty much perfect. And I rather like those blue replacement locks. They are, however, slightly too tight. They work, but they are clearly too tight. So if you are repairing one of these keyboards with these replacement tabs, sand them off slightly. There isn't much needed, but you can see there's a tiny gap here. So keep that in mind if you're repairing one of these keyboards. I'm gonna leave it like this. There's no way I'm removing that cover again. Once in a lifetime is enough. That was an absolute pain. Next up we have the power supply. It has been partially reassembled too, since we had to use it to do all the tests. I'm gonna install all the rivets before we start popping to make sure it's aligned. Almost forgot the bracket that is held in place with the rivet too. For some strange reason, this rivet here is installed with a washer. I see, that's because the rivet can't go deep enough and has to be installed further out. Strangely enough, the fan is installed with security screws. This side of the power supply was actually taped together. I guess there wasn't room enough for rivets on this side before we installed the hard drive. Let's take a look inside the original hard drive and see if there's anything wrong inside here. This drive came with this machine, but unfortunately it's not even recognized by the system. So that kind of indicates that there is a fault on the PCB. But let's take a look inside anyways. The lid has a really sticky seal, so it's kind of stuck. Well, that actually doesn't look too bad. Yeah, this drive doesn't seem to have any mechanical faults. So I'm not ready to give up on this drive yet. So let's put that lid back on. And I'll try some more troubleshooting. And if that PCB is completely shot, I'll see if I can find a drive with a mechanical fault. We can swap the PCB. After all, that is the more common fault on drives this vintage. So definitely not giving up on this drive. But for now, I'm going to install this replacement hard drive. Strangely enough, I think this shield was installed with just 2 screws. And I don't remember which 2. I guess they had some interference issues. They must have had a reason to install a shield back here. The drive is actually installed with rubber dampers in the drive cage. But unfortunately it didn't help when someone dropped this machine. Okay, drive ready to go back into the machine. Okay, time to start installing stuff. So first up, I think is the display cable. And it needs to be clamped down with this clamp here. And then it had copper tape on top of it. I'll try to reuse it. But I have ordered some more in case it doesn't hold up. Next up is the motherboard. At least I hope it is. So much stuff in here. It's hard to remember in what order I removed everything. I guess I could check my disassembly video if I get stuck. Yeah, almost made a mistake here. The power cable for the display has to be fed through before we install the motherboard. Oh crap, it has to be installed before this clamp. Otherwise it doesn't fit the hole. And it has to be fed through from this side, because this side is too thick to go through. I'm not sure if the cables are long enough to install the display after the motherboard. That means we should install the display first. So let's put our recapped board back on the display. That means reconnecting all the flat flex cables. Not so easy. So that took some fiddling. The display, by the way, is manufactured by Matsushita. And it's installed with security screws too. So IBM didn't want you to mess around inside here. Oops. Another minor mistake. There's so many different types of screws to keep track of. Apparently we need standoffs here, not regular screws. There's flat flex contraption here, and on the other side are held in place with these tiny plastic thingies. And then locked down with a peg. A bit tricky to install, but they can be reused. There are similar locks on these PCBs in black. What the heck are these called anyways? They're not very common, but I've seen these in some vintage computers. The only machine I can recall at the moment that uses these is the original Macintosh. The standoffs are for this cover. Then finally we have the shield. And yes, another minor mistake. These security screws apparently should be installed after the shield. Next up are the hinges. And that brings us to the sponsor of this video, PCBWay. Because we're gonna need some help to fix these. Because this display doesn't lock into position when pushed in. These hinges here have a spring, so they push the display back out. That could potentially cause some problems, because it's pushing against the keyboard. Don't know how much this will affect the keyboard, but I imagine key switches don't like to stay pressed in for months and months. So I think these are actually quite important to replace. And back here is the broken latch. There's actually only one of these, so this should be a really easy fix. I'll put some information on the display where I found this project, and I think it's quite wise to replace it. And of course I went with IBM Blue. So now when we push the display in, it locks into position and should stay this way and not push on the key switches on the keyboard. With the display installed, I think we're supposed to pull on these tabs here. So that should be similar to pulling on the hinge here, and that releases the display immediately. So these work great. Awesome. Great fix. Perhaps the most common fault with these machines are the hinges. And I think that's because these springs here are pushing too hard on the hinge. And eventually they break off here. So before I reinstall the hinges, I'm going to grease them with PTFE. I'm going to use a spray to make sure it gets in everywhere. And hopefully these hinges will last. By the way, I use PTFE because it's kind on plastics. If you use the wrong grease, you can actually make things worse and make the plastics fragile. Okay, so this is how it works. The display is pushed in at this end here and then pushed in all the way on this side, and it locks into position. The tab I mentioned before is underneath here, so when you pull on the display it will release like this, and you're free to tilt it out to a suitable angle. I wonder how many hours of engineering it took to design these hinges. These hinges are also attached to ground, presumably to ground this shield here to the chassis, since these hinges are made out of plastic. Yeah, these cables are actually long enough, so we can install the display after the motherboard. But since the display is ready, you might as well install it. This also means the display can be removed without removing the motherboard. And then we have a lid to cover up the cables. So much stuff in this machine. And then this ground cable needs to be fed over to the motherboard on the other side of the machine. Okay, so I won't be able to get this on camera, but the hinge here has a square hole that needs to latch on to this plastic hook here. Yeah, as I thought, that was impossible to get on camera, but actually not very difficult to install. And finally, the display is locked down with one screw on each side. Apparently I forgot to install this rod here. So many custom parts in this machine. The process of restoring one of these is just completely different from any other vintage PC. So apparently we need a stabilizer here too. So if we now pull on these tabs, the display pops out and we can adjust the angle, and when done it's pushed in at the bottom first and then at the top, and it locks in position. Perfect! Next up I think we need to install the LED panel, because I think we're going to have some cables going on top of it next. I think it will be hard to reach once we have installed the diskette drive. The drive needs to be installed in the drive cage first. This drive gave us so much trouble in a previous video, but we managed to fix it eventually. If your drive is beyond repair, by the way, there is a hack to use a standard diskette drive in these machines. I think all the information is available at Ardent. Now we can install the drive in the machine, feeding all these cables through a hole at the bottom here. Before we install the drive, we need to install this latch here that will lock the drive when it's folded in. Okay, let's see if this works. Yep. And with a push, the drive comes out. Next up we have the ground cable. I'm starting to see why these machines were so expensive. They just aren't built for mass production. Just imagine the cost of designing all these custom parts and the tedious assembly of these machines. Next up we have the keyboard cord. And it goes through a hole down in the corner here. This would have been much easier to install before the display. The keyboard cord is then coming up through this hole here, and then it has a painted cover to fill up that hole. Now let's connect the keyboard and make sure everything fits. Yeah, that looks right to me. And now we can install the power supply. It's no small feat to remember in what order to install everything. The keyboard has a tab that turns the machine off when you close the lid, so it has to be folded out when you install the power supply. The larger ground cable needs to connect down here, and the two small cables are connected up here. The green ground cable is connected to the motherboard here. And now I think we need to install the screws for the power supply, because I don't think we will be able to reach them later. One on each side of the fan, and one tiny little black screw inside one of the rubber feet underneath the PC. Next I think we need to install the hard drive with two screws on the inside here. Ideally, you don't wait for 8 weeks or whatever to reassemble this machine, but I had to because I was waiting for parts. The hard drive also has a tiny black screw through one of the rubber feet underneath. The battery and the speaker goes down here in this corner, so not much left now to install. I'm going to replace this battery with something more modern later, but that's for another day. And the last part to go in is the riser. I installed the screws on the motherboard off camera because they are kind of obvious. All the standoffs for the connectors are installed on top of the shield. Okay, only thing left now is to connect everything. So the ground cable from the display goes on top of the shield here. Then we have the green ground cable here. Apparently this thin green wire grounds the riser and the motherboard to the chassis. Now we can connect the display and clamp it down with this screw here. And since we are in this corner, we can connect the speaker and the battery to the motherboard. And down in this corner here, we've got the LED panel and the diskette drive. Wow, that is a tight fit. I'm starting to see the light at the end of the tunnel now. So let's connect some power to the motherboard and the display. And the final cables are for the hard drive. I'm gonna skip all the zip ties for now until I have done all the tests. I have been working on this project for quite a while now, so I also had the time to pick up some spare parts, like this nice cover here. The door on the original cover was completely smashed, but this door is in a great condition. The cover is also held down with 2 screws underneath the machine. I have replaced a few parts in this machine, just because they were in a nicer condition. I almost forgot. This machine had a sticker on the front. I removed it when I washed the case, but I'm going to leave it inside the machine back here to preserve this machine's history. And the final part to go in is the cover for the diskette drive. It has tabs on the inside, so I think it just goes on top of the drive, and then I think it slides down. Yep, that totally worked. Well, at least one thing was easy on this project. Okay, finally done. Wow, what a reassembly. Fingers crossed. Hard drive spins up. I can hear the fan in the power supply. We've got a bright orange display. It posts. Since we removed the battery, we have to set the clock with the reference disk. Okay, the diskette drive works. Oh, I forgot to fold out that display. This looks kind of nuts. This machine looks completely bonkers with everything folded out. Let's just set a random date. It's too bad this display flickers on camera. I wish I could show you how gorgeous that display is. It looks absolutely amazing. It's very bright, sharp and vivid, and very orange. Well, I can hear the hard drive spins up, and it boots. Awesome. So I didn't make any major mistakes. This is now fully working and reassembled. IBM P70 in great condition. The replacement locks on the keyboard look like they belong on this machine. It's not a perfect color match, but they're similar enough to the brightness slider and the eject button on the diskette drive. So they look like they belong on this machine. The only thing I'm missing is a big red power switch. I'm tempted to replace it. Well, I think this is the end of this project. But if you have any thoughts on what we could try to overclock this IBM, let me know and we'll try it in another video. Meanwhile, check out the disassembly video of this P70. I'll end by saying thank you to my patrons. I appreciate your support. If you want to support me too, consider becoming a patron. Patrons get ad-free early access. If you like this video, let me know with a thumbs up in the comments. If you're a regular viewer, consider subscribing to this channel. Thank you for watching. I'll see you next week.